Hi, fourth graders. So I am here to work on your next math lesson. In the new packet that you received last week, within that packet there were all of your math lessons that we'll be doing between now and Christmas break, and each lesson is stapled together, so you've got the lesson and the independent work that you're going to need to do stapled right in there, so that way you know which papers you need to do, which ones you have to follow along with me, and then stapled the last page is the one that you have to do independently, and take pictures of the front and the back and attach them to this lesson or email them to me. So I just want you to be aware within that packet has all of the lessons, so you won't be getting another packet from me unless they extend our remote learning, which, cross our fingers, we will be back together after Christmas break. So I need you to get in front of you your Module 3, Lesson 4, which is the very first one. I put them all in order, so you shouldn't have to mess around with them. That's the very first one. It starts on page 65. So you need that in front of you and a pencil so you can follow along while we do the lesson together, and then you can work on the last sheet independently. All right, I will get my camera ready and we will begin. So Module 3, Lesson 4, we are going to be using comparisons to solve problem situations. And when we are done, you are going to be able to write equations with letters for the unknown values to model and solve multiplicative and additive comparison problems. And remember, multiplicative means that we are going to multiply. Right? We're going to be using the symbol multiply. Additive comparisons, we are going to be adding. Okay? So I just want you to remember, multiplicative means multiply, additive means to add. So let's read our first problem. Anton is making chili for lunch at a soup kitchen. He uses 8 cups of navy beans. The recipe calls for 3 times as many black beans as navy beans. How many cups of black beans does Anton use? Well, let's look. So first, letter A wants us to draw a box around what we want to know. What are we trying to figure out? What is our end product? What, after doing this problem, what do we need to know? We need to know how many cups of beans, or black beans, I apologize, how many cups of black beans Anton uses. So how many black beans does he use? How do we know? Well, we're going to underline the facts we're going to use. Well, we know he's going to use 3 times as many black beans as navy beans. And to help us figure this out, we need those navy beans. So we know we need 8 cups of navy beans, and he's going to use 3 times as many black beans as navy beans. So what type of comparison are we solving? Are we solving an additive comparison or a multiplicative comparison? 3 times as many black beans as navy beans. Times as many. That's your clue. That is, this is a multiplicative. We are going to be multiplying to find the answer. So now we need to identify the unknown in the comparison. What is the unknown? Is the unknown a smaller quantity? A larger quantity? How many times as many? How many more or fewer? Well, we know that our navy beans are 8 cups. The recipe calls for 3 times as many black beans as navy beans. So which is more, navy or black? Black beans are more. So we are looking for a larger quantity. Our answer needs to be bigger than our navy beans. So what equation could we write? We are going to write a multiplication equation, right? So we know that we have 8 times as many as 3 is going to equal our unknown. Our unknown is our black beans. So what is 8 times 3? 8 times 3 equals 24. So n equals 24. Our unknown equals 24. So Anton uses 24 cups of black beans. So this part is important to help us figure it out. This part, knowing that we are looking for a larger quantity, helps us to figure out that we need to multiply. Plus, it talked about times as many as, right? All right, next page. Some students are helping out at a soup kitchen. They bring in 42 cases of water and 7 cases of juice. How many more cases of water than juice do the students bring in? Well, we know that some students are helping at a soup kitchen. They bring in 42 cases of water and 7 cases of juice. How many more cases of water than juice do they bring in? So first we're figuring out the type of comparison. Is it an additive or a multiplicative? I don't see any times as many as in here, right? So it must be an additive. So what is our unknown? How many more cases of water than juice do the students bring in? How many more? So our equation is going to be, we know there are 42 cases of water. We know there are 7 cases of juice, but we don't know how many more cases of juice than water, or how many more cases of water than juice there are. So we're going to need to figure out what is 7 plus what equals 42. Well, this one I can do a subtraction, right? I can do the inverse operation to figure out my unknown. So 42 minus 7. So I can't do 2 minus 7, so I'm going to have to do some regrouping. So I get 12. 12 minus 7 is 5. Bring down my 3. So n equals 35. So the students bring in 35 more cases of water than juice. Now, even though we had to subtract to find the answer, it's still an additive comparison because you have to add your 7 to an unknown to get the total, right? Your total is really the number of cases of water. That's what you're comparing. You're comparing the juice to the water. And we're trying to find the difference between the two. So our difference actually is part of the additive. So that's why we're doing the inverse or the opposite. Remember we talked about how the inverse is the opposite? All right. Let's check for some understanding. We need to write an equation to model and solve the problem and use n for our unknown. Tina donates 3 fewer cans of corn than green beans. She donates 15 cans of green beans. How many cans of corn does Tina donate? So what are we looking for? We're looking for how many cans of corn she donates, right? We know that she donates 3 fewer cans of corn than green beans. She donates 15 cans of green beans. So our additive, right, this is an additive, so 3 plus n equals 15. Because we know she's getting 15, right, of green beans, and there's going to be 3 fewer. So that's how we get our 3 plus n equals 15. So now, to solve this, 15 minus 3 equals 2, right? And 1 is 1. So she donates 12 cans of corn. Number 2. There are 42 students and 6 adults volunteering at the soup kitchen. How many times as many students as adults are volunteering? So they really want to know, what is the difference between the number of students and the number of adults? How many times more students than adults, right? How many times as many students as adults? So we're comparing students as adults, and we've got that how many times, so we know this is a multiplicative comparison. And we know there are 42 students and 6 adults. So we know that our unknown times 6, this is our times as many as, equals 42. So what number times 6 equals 42? Or you could think of it as 42 divided by 6. Remember, we do the inverse, equals n. So what times 6 equals 42? There are, I hope you got 7 times as many students as adults. 7 times as many students as adults. If I multiply 6 times 7, I would get how many students there are. So there's 7 times as many students as adults. Okay, so now we're on the on your own part. So remember, you can pause your video here and try this independently, and then come back and check your answers, or you can just keep moving on with me and do this along with me. Okay? So we're going to write an equation to model and solve the problem. Use n for our unknown. Mr. Torres makes 12 cups of rice and 8 cups of couscous for the soup kitchen. How many more cups of rice than couscous does Mr. Torres make? How many more cups of rice than couscous? How many more than? More than. So is this an additive or a multiplicative? More than. This would be additive. Okay? So how many more rice than couscous? So my adding would be 8 plus n equals 12. 8 plus my unknown is going to equal 12. So then I can do my inverse, 12 minus 8. 12 minus 8 equals 4. So n equals 4 more cups of rice. Number 4. Carrie. Oh, and they even spelled it the same way as my name. Isn't that nice? I never usually see my name spelled the same in a book. Carrie spends 45 minutes making chicken noodle soup. That is 5 times as many minutes as she spends making a salad. How many minutes does Carrie spend making the salad? So which do you think she spends more time making? The salad or the chicken noodle soup? Remember that word that is? When we see that in there, that means that this number is going to be more than how much time she spends making her salad. That is. So that means this is going to be 5 times our n, our unknown, our salad time, equals 45. We want to know how many times she makes, how long it takes to make her salad. Well, the chicken noodle soup is 5 times more, many minutes more than it takes for her to make her salad. Chicken noodle soup as her salad. So 5 times n equals 45. So what times 5 equals 45? Count by 5s till you get to 45. Or we could do our inverse, right? 45 divided by 5 equals n. And our n equals 9. 9 minutes making the salad. So it only takes her or me, whichever, 9 minutes to make the salad. 45 minutes to make chicken noodle soup, 9 minutes to make salad. All right, now we get to do a little line drawing. We're going to try to find the match from our word problem to the comparison problem. We're going to see which ones match. Okay? Sam has 18 cards. That is 3 times as many cards as Lena has. How many cards does Lena have? Well, already, this is the bigger number. So Sam has more than Lena. That is 3 times as many cards as Lena has. So times as many, we already know that this is going to be a multiplicative comparison. So I know it can't be this one, it can't be this one, and it can't be this one. So it's either 3 times 6 equals n times 6 equals 18, or 3 times n equals 18. So 18, remember Sam has the most. 18 has to be our total. So now we've narrowed it down to one of these. That is 3 times as many cards as Lena has. So that is your n, right? Lena's cards times 3. So the two furthest away from one another would match. 3 times n equals 18. Lena has 6 cards. Sam has 18 cards. How many more cards does Sam have than Lena? How many more cards? Lena has 6. Sam has 18. So is this a multiplicative or an additive? This must be an additive, right? I don't see any times as many as in there. I see how many more cards. So this has to be one of our additives. So we know that Lena has 6, Sam has 18. How many more cards does Sam have than Lena? So 18 must be our total. And our unknown is going to be added to 6 to equal 18. So which one of these has 6 added to an unknown and it equals 18? 6 plus an unknown equals 18 is right here. 6 plus n equals 18. I'm actually going to write these. So this first one is 3 times n equals 18. The second one is 6 plus n equals 18. So these two are done. So we're good with those two. Okay. Sam has 12 more cards than Lena. Lena has 6 cards. How many cards does Sam have? Well, Sam has 12 more cards than Lena. Lena has 6 cards. Does it sound like it's a multiplicative or an additive? I hope you're thinking additive. I don't see any times as many as again. So now we're down to this one and this one. Sam has 12 more cards than Lena. 12 more cards than Lena. Lena has 6 cards. How many cards does Sam have? Does it tell us how many cards Sam has? No. And he has 12 more than Lena. So we don't know Sam's. So Sam's is our unknown down here. We don't know the total. So it would be 6 plus 12 equals n. Lena has 6 cards. Sam has 3 times as many cards as Lena. How many cards does Sam have? So we want to know Sam's cards. And we know that he has 3 times as many cards as Lena. Lena has 6 cards. So Sam has 3 times as many cards as Lena. So we know that it must be 3 times 6 equals n. Sam has more than Lena. So neither one of those numbers can be the equals side, right? Neither one of those numbers can be the answer, the bigger number side. So it has to, that's what we're trying to find, is what our total is. Last two. Sam has 12 more cards than Lena. Sam has 18 cards. how many cards does Lena have? So we want to know Lena's cards. Sam has 12 more than Lena, and Sam has 18. We don't know Lena's number. Is this an additive or a multiplicative? This is an additive. There's no times as many. The only additive we have left is this one up here, and it is correct. 9 plus 12 equals 18. Or, sorry. N plus 12 equals 18. I didn't mean to say 9. I apologize. So finally, this one must be our last one, but let's double check. Sam has 18 cards. Lena has 6 cards. How many times as many cards does Sam have as Lena? How many times as many cards? There's that. How many times as many? So it has to be a multiplicative. We know that Sam has 18 and Lena has 6. So we want to know how many times more, how many times 6, how many times more equals Sam's, equals 18. So it must be n times 6 equals 18. Alrighty, and our last page. So Ms. Novak volunteers 15 hours at the soup kitchen this week. That is 5 times as many hours as Gina volunteers. How many hours does Gina volunteer at the soup kitchen? Use inverse operations to write 2 different equations to model the problem. Let H equal the number of hours Gina volunteers. So we want to know how many hours Gina volunteers at the soup kitchen. Ms. Novak volunteers 15 hours. That number, 15, that is 5 times as many hours as Gina volunteers. That number is. So that means Ms. Novak has to volunteer more than Gina because that number is 5 times as many hours as Gina's. So that goes here. That goes on the answer side. That is your product. Now, times as many. We know this is going to be a multiplicative. So now we're left with our 5 times our unknown, which is going to be our H. 5 times H equals 15. What times 5 equals 15? Count by 5s till you get to 15. 5 times 3 equals 15. Now we also want to do the inverse. What is the inverse of multiplication? The inverse of multiplication is division. So how would I write this? Right here, 5 times H equals 15 as a division problem. Well, my answer, right, my 15 has to be first. 15 divided by, I want to get all my numbers on the same side. 15 divided by 5 equals H. 15 divided by 5 equals 3. Which they should have the same answer, correct? So Gina volunteers 3 hours. Oops. Oh my goodness. My brain is getting ahead of my writing. Or my writing's ahead of my brain. I don't know which. It's one or the other. All right. Number 7. We're going to write an equation to model and solve the problem, and we're going to use n for our unknown. Joshua makes these centerpieces. He makes 2 fewer centerpieces than Betty. How many centerpieces does Betty make? Who makes more centerpieces, Joshua or Betty? I hope you're saying that Betty does, because it says he makes 2 fewer centerpieces than Betty. The he here is Joshua. Joshua makes 2 fewer centerpieces than Betty. And we want to know how many Betty makes. How many centerpieces did Joshua make? He made 4. Plus what number are we going to use? 4 plus 2, right, is going to give us our unknown, which is Betty. So 4 plus 2 equals? N equals 6. So Betty makes 6 centerpieces. Betty makes 6 centerpieces. So 4 plus 2 equals our unknown. 4 plus 2 equals 6. Our unknown is 6. So Betty makes 6 centerpieces. All right. 5 students sign up to be cooks at the soup kitchen. 4 more students sign up to be servers than cooks. How many students sign up to be servers? Well, we know that there are 5 cooks and there are 4 more. Do we hear any times as many as? I don't hear any times as many as. It just says 4 more. So I have 5 cooks and 4 more students signing up to be servers than cooks. So 5 plus 4 equals N. N equals 9. So there are 9 servers. And finally, our last one. 4 times as many students sign up to be cleaners as cooks. How many students sign up to be cleaners? Well, we have 5 cooks and 4 times as many students sign up to be cleaners. So are there more cooks or more cleaners? There are more cleaners because 4 times as many, right? So 4 times as many. So 5 times 4 equals our N, our unknown. 5 times 4, N equals 20. So we have 20 cleaners. All right, so you are going to do 3.4. When you are done 3.4, you are going to then take pictures of it and send it to me. You do not have to draw the bar model. For number 1, you just have to do the equation and solve. You do not have to do number 3. So no bar model, no number 3. You can cross that one out. And that's it. You should be able to do all the rest. Okay, the only ones I don't want you to do, you don't have to draw the bar model, and you do not have to do number 3. When you are finished, please take pictures front and back and send them to me. All right, guys. I hope you have a great rest of your day, and I will see you soon. Bye.